My name is Oscar Monje, a member of the Space Crop Production Team at the Kennedy Space Center. I will discuss space crop production in 2030. Space crop production systems are designed to mitigate the risks of inadequate food and nutrition during long-duration NASA exploration missions taking more than 3 years. Processed and prepackaged food loses nutrients during processing and during storage, and may not provide the expected nutritional content or have the same taste when consumed. Crop production systems provide fresh pick-and-eat crops like lettuce, radish, and peppers, grown in situ for crew consumption during Mars transit and surface habitat missions. They supplement the astronaut food system with bioavailable vitamins and amino acids that degrade during long-term storage. On Earth, crop productivity is determined by interactions between genetics, environment, and management. For example, higher productivity is achieved in vertical farms compared to traditional field agriculture when the environment, that is the light, the CO2 concentration, the humidity, and temperature, are controlled and water delivery is optimal. In space, crop yield is affected by the spaceflight environment and management, radiation, and the distance from Earth. In the spaceflight environment, reduced gravity affects plant growth indirectly. Lack of buoyancy-driven convection increases boundary layers around plant organs. Phase separation affects how fluids and gases behave, and capillary forces cause root zone moisture redistribution. These effects are mitigated by improved ventilation and root zone aeration. Research on veggie and the advanced plant habitat suggests that soilless, gravity-independent watering and nutrient delivery systems are more sustainable. Much more radiation is present on a Mars transit mission than on an ISS mission. However, the effects of deep space radiation and partial gravity beyond low Earth orbit, the Moon, and Mars are unknown. Distance from Earth affects the logistics of resupply and robustness of the plant growth hardware. In 2030, space crop production will have developed non-destructive plant health monitoring technologies, imaging systems, and artificial intelligence, develop microgravity independent water and nutrient delivery systems to enable crop growth demonstrations on Artemis lunar landers and habitats, supply of pick-and-eat crops to crew food systems on Mars transit missions, and study the effects of combined partial gravity and deep space radiation on the Moon. Finally, crop production systems on Gateway will be used to study the effects of deep space radiation and microgravity on plant growth, demonstrate automated crop space production systems for Mars transit, as well as evaluate food safety during long-duration missions.